So class, today we're going to look at number 3. It says methane reacts with oxygen gas to produce carbon dioxide and water. Write the chemical equation below, then balance it. We should already know that the formula for methane is CH4, and it reacts with oxygen gas. We should already know the formula for oxygen gas is O2. To produce, that means there's a yield sign there. To produce, these are the reactants. These are the products. So it produces carbon dioxide. We already know that's the chemical formula for carbon dioxide. And it also produces water. So with this, we're going to have 3 things we have to do. First, we have to balance the chemical equation, which you should have done the other day, last Wednesday, I believe. But if you did not, we're going to be doing it, talking you through it today. And the second thing is going to be determining what type of chemical reaction it is. And the third thing is to write the equilibrium chemical equation. So we're going to be doing those 3 things today for this. So the first thing you need to do is you need to go ahead and list down the different types that numbers of what you've got on both sides. Starting off with, we have carbons. We have 1 on the left side. And carbon, we have 1 on the right side. Hydrogens, as you can see, we have 4 on the left side. And we have 2 on the right side. And then we have oxygens. We have 2 oxygens on the left. And 2 plus 1 or 3 oxygens on the right side. So there you've got those. Really, you should have put the shape in there. Let me see if I can get the shape in there correctly. We'll put a line in there between. At the yield sign, the first thing you should do on these is separate it between the left side and the right side. Left side, like I said, is the reactants. And the right side is the products. Be patient, I'm slow with this stuff. So we'll say, let me go up here and list these down, make sure we got these. These are the reactants. And these on the right-hand side are the products. Just so we won't get confused. So the reactants are CH4 and oxygen gas. Methane and oxygen gas are the reactants. And they produce carbon dioxide and water. So now you look at those after you listed these down, each element of how many they've got. Make sure you put these in the same order. And it's always best to put down hydrogen and carbons last when you're doing these, but it doesn't always work. But most of the time it'll help you. So you've got 1 carbon on the left, 1 carbon on the right. Remember, your answers is what the numbers are up here. These are not your answers. Your answers are up here. 1 carbon left, 1 carbon right. But now you have 4 hydrogens and you only have 2 hydrogens there. So what it's best to do then is go ahead and just start trying numbers. Try a 2 there. That gives you 2 times 2 or 4 hydrogens. So now you can change that 2 to a 4. So now you've got the carbons are 1 to 1. The hydrogens are 4 to 4. But now look at the oxygens. You have 2 oxygens on the left. And you have 2 plus 2. 2 are here, 2 plus there, so it makes it 4. So now they don't balance. You have 1 carbon on the left, 1 carbon on the right, 4 hydrogens on the left, and 4 hydrogens on the right. Only 2 oxygens on the left, 2 oxygens on the right. So you can go ahead and say, well, I'll just use 2 molecules of oxygen gas in this reaction then. So that change. So if you use 2 molecules of oxygen gas, that makes now you have 4 oxygens on the left. So now we have 4 and 4, so we should be good. So you have 1 carbon on the left, 1 carbon on the right, 4 hydrogens on the left, 4 hydrogen on the right, 2 times 2 or 4 oxygens on the left, and 2 plus 2 is 4 oxygens on the right. I always like that. So you have your chemical formula is balanced, but I like to stick 1s in there. You're not required to put 1s there, so if you don't do it, there's no big deal. But I like to put the 1s there to give me a place setters. So like I said, this is not required. Most people will not require you to do that. So now you have it. So the balanced equation. So this is balanced now. Balanced equation. The balanced chemical equation is. So now you have the balanced chemical equation is 1 methane molecule plus 2 oxygen molecules yields one carbon dioxide molecule plus two water molecules. We're going to eventually have those coefficients mean moles, but that's coming up later, which is a lot bigger. You don't normally deal with moles when you're trying to mix something up, okay? Let me try and get rid of some of this mess down here. So we've already got the chemical formula balanced. So now we have to determine the type of chemical reaction. Determine the type of chemical reaction. So let's see if I can do this. If you look at types of chemical reaction on your slides, I believe it's slide number 4, but it says that the synthesis is small molecule plus another small molecule yields a bigger molecule. Is this a small plus a small yields a big? No, we have two products over here. So it's not synthesis. Let's go to decomposition. Decomposition. Oops. I messed that one up, didn't I? This one is defined as a bigger molecule breaks down to form a smaller molecule plus another smaller molecule. And it could be 2 or 3 different, 3 or 4 different ones. Don't be limited by just having 2. But the decomposition is a bigger breaking down the 2 smaller. As you can see, that's not what the case is here. Then it says, the third one is combustion. Combustion says a molecule that has a carbon and a hydrogen only. They call that a hydrocarbon in your chemistry reference table. This is a hydrocarbon because it only has carbon and hydrogen in it. Then it reacts with oxygen gas. So it's met the first 2 requirements to produce carbon dioxide and water. So a combustion reaction says it's a hydrocarbon plus oxygen gas yields carbon dioxide plus water. And that's exactly what we're doing here. We've got hydrocarbon reacts with oxygen gas to produce carbon dioxide and water. So this is a combustion reaction. So the type of chemical reaction this one is combustion. So there's an answer to your other question there. Combustion. Let's see if I can make it a different color. I'm tired of that purple. Let's make it blue. There you go. Combustion. So you've got 2 of your answers done. So you've got your balanced chemical equation at the top. And the type of chemical reaction is combustion. I'd like to make this smaller so we can have room. Then the last thing is to write the equilibrium chemical equation. To write the equilibrium chemical equation, the only thing you have to do is the first thing you do is you take your products, which are here, are going to be, you put those in brackets, CO2, and we'll leave a space, and we'll come back in a second and get that. And this is kind of strange, but you multiply it by the other product. Let's go back and fill those in for the subscripts. It takes a little bit of time to get those done, so just bear with me a second. Subscript of 2 there. And then the water also has a subscript of 2. So you've got those done. But then it says what you need to do after you put down those into brackets, those on the denominator, put those on the numerator, rather the products on the numerator. Then you use these coefficients that are in front of you as the exponents. So we really don't have, you don't have to put a 1 there because the 1 you don't put down, okay, just like in math. But here you have 2 of those. So what we have to do, and let me put the line down here so I won't be having to fool with that later. So continuing on to put that, so you have to deal with that too. So you have to put that as an exponent for the H2O molecule. So what you do here is you go to put a superscript of 2. So now you've got for the equilibrium chemical equation, you've got the CO2 in brackets and the H2O in brackets with a superscript of 2. What you're really doing here, and not all, let me explain to you real quick, not all chemical equations are equilibrium, especially unless they have specific conditions going on, like really high pressure or really low pressure, or really high temperatures or really low temperatures. But we're going to pretend that all of these react and that we are able to meet those requirements, even though we won't mention that when we're doing equilibrium chemical equations. We're just going to be treating those as if they all work the same way, okay? So we've got the products taken care of. We have CO2 in brackets with a 1, but you don't have to put the 1 there as your superscript there. H2O in brackets, and you have 2 of those. Then you go to the denominator. So what you need to do is list your reactants there. Once again, you have CH4, put it in brackets, CH, and the other one is O2, right? O. Okay, see CH4. See why I don't take my time in class sometimes when I'm doing those worksheets to type these in. It's irritating. O2. So we got those. Say, is this correct? Well, let's see. We're supposed to have 1 methane. We do. Oxygen. Oh no, we have to have a 2 there because we have a superscript of 2. This is a coefficient. Remember, these are coefficients. These are subscripts. These are coefficients. That means we have 2 molecules of oxygen gas. This means I have 1 molecule of methane, for example, okay? And later on, we're going to be talking about moles, and next week sometime we'll be doing moles. But now we have to put that 2 there. So we have to represent that 2. We have to put that as an exponent, or really, it's really supposed to be called a superscript. It's not really an exponent, but it could be. So now what you've got the product CO2 in brackets, and notice it's at times, it's not addition, H2O over CH4 and CO2 squared. What this is really used for is if you have some really large chemical formulas, like I gave you the chemical formula for casein, which will be starting on our lab tomorrow. But it's got some humongous numbers on there, humongous maybe products or a lot of things go into it. So what you do is if you had, say you was reacting with something else over here, I'm just putting an example, reacting with something that had, just say, 4O, and then it had 2 there. Now don't write this down, I'm just kind of explaining it to you, okay? 2. Oops. 2. Then what you can do is you can say, well, okay, you have this would be written as O I'm not going to worry about that. It's irritating. You'd have this as O2 with a 4. Everybody see what I'm talking about? You'd have this as an O2. So now I'm back on that default. There you go. This is what I should have done. O. And now you're going to have 4 of those, right? 4. Put down the 2 there. So when you're starting to do, like, if you have a whole lot in common, remember the answer is right here. Don't get confused with all of this right here is just to kind of help you understand why you're using it. But the thing over here, this is the answer. This is the equilibrium chemical equation. This is just to help you understand. For example, you have 2 of these here, and you have 4 over there. So the way you can use this is you take 4 of those, cancel out 2 of those, and that'll cancel out 2 of those. That'll leave this. Okay, well, that's it for today. I hope you understand that. Tomorrow we're going to be doing some more of this. We're going to be working on balanced chemical equations and stuff for quite a while, probably another week or so, and then we'll get into stoichiometry. Tomorrow we'll be doing that lab, so it was nice having all of you. You got to take care. I'll talk to you tomorrow. Be good, be happy, stay safe.